All right, in section 10.1, we start learning about fractional exponents. And what fractional exponents are, they're the same thing as maybe our square roots. For example, let's look at this. If you have a fractional exponent, the bottom number tells the root you are taking. So for instance, this would be a square root. So I could write the square root of 81, and then the top number tells what power you're going to raise that to. Power to raise 2. So you take the square root first, and then you raise it to the power that's in the numerator. Now, if the numerator is a 1, you're not really changing the number because anything to the first power is itself. But 81 to the 1/2 is really the same thing as the square root of 81, so it's going to be 9. Okay, let's look at another one. Let's look at number 3. What does it mean if it's to a negative fractional exponent? Okay, well, remember from when we talked about negative exponents, that means you move it to the bottom. Okay, you move the whole term to the bottom and you make the exponent positive. So this becomes 1 over, and then you can think of this as the square root of 49, because you're just saying you want the square root of it, and you would say, well, raise it to the first power when you finish, except that, again, raising to the first power doesn't change the number, so 1 over square root of 49 is just going to be 1 over 7. Now, one like number 5, you have 4 to the 3/2 power. That means, okay, if you think about what I said above, you're going to take the square root of 4, and when you get through taking the square root of 4, you're going to raise it to the 3rd power. Well, what is the square root of 4? It's 2. Okay, so you're going to take 2 and raise it to the 3rd power, and you would get 8. That's how this works. Let's look at something like number 11, just because I know it looks a little weird. 4 to the negative 0.5 power. Isn't that the same? Isn't 0.5? Isn't that a half? So it's 4 to the negative 1/2 power. Now that doesn't mean it's like a negative 4 or something. It means, okay, you have a negative exponent, so remember that this is on the top of a fraction. You're going to move the whole thing to the bottom and make the fraction positive, and then you'll fill in with a 1 on the top if you don't have anything else left. That's just 1 over the square root of 4, and so that's just 1/2. And then if you look at 15, you have to remember your exponent rules when you're doing this. If you have 5 to the 1/3 to the negative 3 power, you could do this a couple of ways, but don't you want life to be as easy as possible? When you have a power to a power, do you remember that you just multiply? When you have an exponent that's a power to a power, well, what's 1/3 times negative 3? Well, that would be negative 1, right? So you could do this a lot harder way, but this is the easiest way to do it, is use your exponent rules here. Well, 5 to the minus 1 power means draw a fraction bar, because it's really on the top of a fraction. We just don't write it that way. And move it to the bottom and make the exponent positive, fill in with a 1 on top, and you just get a 1/5. Now, when you look at this, you may at first, there's some things that might come to mind. You may think, hey, this 2 means there's 2 copies of these things, and that's true. But before you write 2 copies and multiply it out, look at it this way. If you look at it as a PEMDAS kind of thing, and let's simplify inside the parentheses first. What does 9 to the 1/2 mean? Well, that just means the square root of 9. And then you got another term, 16 to the 1/2. What does that mean? That just means the square root of 16. Oh, if you change it over to radicals, a lot of times stuff starts making sense. And that's the thing. A lot of times if you're looking at something one way and it doesn't make sense, like it's fractional exponents, change it over to radical and see if those rules help you simplify it easier. And vice versa. If you've got something in a radical form and you can't seem to figure out what to do with it, maybe try changing it into fractional exponents and seeing if maybe there's some rules there that might help you. Here, if you look at this, the square root of 9 is just 3, and the square root of 16 is just 4. So if you're still thinking PEMDAS, you can go ahead and say, well, 3 plus 4 is 7, and then this just becomes 7 squared is 49. All right, in a problem like this, if you get confused, you can always, they're just wanting you to write this in exponential form. They're not really wanting you to simplify it, so you really got to be careful to read the exponents. Um, so here's what you kind of think here. Since they want it in exponential form, what's another way of writing the square root of x to the third y to the fifth? Well, if I write it as a fractional exponent, that's just saying the whole thing raised to the 1/2 power. And now that you've got it like that, you can use your exponent rules. If you've got several things in parentheses and there's an exponent on the outside, that exponent has to go with each term inside. So what we really have is x cubed to the 1/2 power times y fifth to the 1/2 power. And then you could say, okay, well, since I've written it like that, now I see that I've got a power to a power, so I can just multiply. And so you'd get x to the 3 times a half would be 3/2 power. And that the y would be 5 times a half, which would be to the 5/2 power. Okay, with a problem like this, they ask us to express it in simplest radical form. Okay, when you have two similar roots, like I've got two cube roots here, and they're written separately and multiplied, you can multiply underneath the radical. You can take these two things and put them underneath one cube root, just like you could do with square roots, okay? Well, that's the cube root of 16. Okay, now, are there any perfect cubes in 16? Yes, 8 is a perfect cube. If you remember, 8 is 2 cubed. Okay, so one way to do this is to rewrite 16 as 8 times 2 and say, well, the cube root of 8 is 2, but I've got a 2 left in there that can't come out. That's one way to do it. Another way to do it, if I start back up here where I had the cube root of 16, is I could go and prime factor 16. If you remember, if you don't know you could write out a list of cubes and use your calculator to even help you do that if you don't know them. And that honestly is kind of the way we'd rather get to doing the problem. But if we need to, we could prime factor 16. 16 is, we know it's 4 times 4, but each 4 is 2 times 2. So we would have 1, 2, 3, 4 2's underneath the radical. Now a cube root is saying we're looking for 3 of a kind inside. Well, there's 3 2's. So there is one set of 3 2's. That means 1 2 comes out, and then I have the cube root of 2 left over. So you could do it either way. If you need to prime factor. The problem with prime factoring, well, I don't know. It's more of a preference thing. I won't even complete the sentence that I started to say there. We'll look at another one. We'll go to 43. Okay. Okay, let's look at the A problem first. I just went ahead and wrote down both problems so they'd be here. If I want to get A by itself, how could I get rid of that exponent 3/4? Well, if I use the idea of when I do a power to a power, I multiply exponents. Think about it this way. What if I took the reciprocal of that 3/4? It would be 4/3. When I would multiply the 3/4 times the 4/3, because for a power to a power on an exponent you multiply, wouldn't they cancel each other out and it would just be a to the first power? Okay, but if I did it to one side, I got to raise the other side to the 4/3 power. Okay, now that's going to require me to simplify some stuff. Now when I look at 8 to the 4/3 power, I may not know what that is right off the bat because maybe I'm not so familiar with fractional exponents. But what if I break it apart a little bit at a time? This cube on the bottom means we're going to take the cube root of 8, and then when we get done, we're going to raise that to the 4th power because that's the exponent on the top. So what is A really? Well, the cube root of 8 is just 2. But what's 2 to the 4th power? Oh, it's 16. That's 2 times 2 times 2 times 2. It's 16. So we would get the solution A is 16. So this is how you can solve things if you have fractional exponents. To get the variable by itself, you can multiply by the reciprocal of the exponent. So if you use that idea, let's go look at part B now. This is 3x plus 1 to the 3/4 power. So how could I do it? I could do it the same way. I could say, well, to get rid of that exponent that's a 3/4, I could raise it to the, okay, I'm going to have to do that on a separate line. It's just not going to work, is it? I can take the 3x plus 1 to the 3/4 power, and I'm going to raise it to the 4/3 power, and that will get rid of that exponent, okay? But if I do it to one side, I got to do it to the other side. Okay? So now this 4 and this 4 would cancel out, and that 3 would cancel out. So my exponents go away with this method of solving, and I just get 3x plus 1 is 8 to the 4/3. Well, we just did 8 to the 4/3. If you look over at the A part, do you realize that's what you just did over here? It was 16 because the cube root of 8 is 2, and 2 to the 4th power is 16. That's actually what the part A was kind of having you do that little piece by itself. They were kind of being tricky there. Okay, if we want to know what x is, because we haven't solved it yet, to solve it is to tell what x is. To get x by itself, we would first subtract 1 from both sides, and we get 3x equal 15, and then to get x by itself now, we would divide both sides by 3, and we would finally get our answer, x equal 5. Okay, so let's look at one like 45 if you're having trouble with that. What I would do first here would be simplify this a little bit. Now this negative 1/2 is only attached to that y, so I could rewrite this as 2 over, and I could take that y to the negative 1/2, I could move it to the bottom of the fraction bar and say that's y raised to the 1/2 power. But you know what? I still don't like the way that looks. Isn't y raised to the 1/2 power the same thing as the square root of y? So I'm going to rewrite it that way. Now if you look at this now, I have a fraction on one side and a whole number on the other. I could make this into the right-hand side into a fraction, and if you think about why I might want to do that, if I have a fraction equal a fraction, can't I cross multiply to solve? So that's what I'm going to do. I'm going to say, well, 2 times 1 is 2, and 10 times the square root of y would be 10 square roots of y. Okay, so I'm trying to work to get that y by itself. So let me first do this. If I'm doing PEMDAS backwards, I would divide first. Divide both sides by 10 first to get rid of the 10. That would be 2/10, which would reduce what to 1/5? 1/5 is equal to the square root of y. Now what am I going to do to get y out from under that radical? What's the opposite of square rooting something? I could square both sides. If I square the square root of y, I just get y. And if I square 1/5, 1 times 1 on top is 1, and on the bottom, 5 times 5 is 25. I get y equal 1 over 25. Now the part B is much like this. It's just that they've just kind of tweaked it a little bit. If you look at part B, it has 2y to the negative 1/2 equal 10. Okay, so what I would do is I'd say, okay, first of all, I would say, all right, move the whole 2y, it's in parentheses, and then it becomes to the positive 1/2 is equal to 10. Okay, now that's just the same thing as 1 over, anything to the 1/2 power is the same thing as the square root, so I'm going to rewrite it as the square root of 2y because I can think about that a little easier, and that's equal to 10. And just like I did on the A part, let me turn this into a fraction on the right-hand side so I could cross multiply. 1 times 1 is 1. 10 times square root of 2y is 10 square root of 2y. So I'm trying to get y by itself, and it's inside that radical there. So let me first get rid of the 10 by dividing both sides by 10. I have 1 over 10 now is equal to the square root of 2y. And then if I want to get down to that y, what do I do next? Well, I got to get rid of the radical. What's the opposite of square rooting something? It would be to square something. So now I'm going to get 2y, because square root of 2y squared is 2y. On the left-hand side, 1/10 squared. 1 times 1 is 1, and 10 times 10 is 100. Oh, now if I want to get y by itself, all I have to do, I could divide both sides by 2, but wouldn't it be easier if I just say I'm going to multiply by 1/2? Because 2 times 1/2 would be 1. So if I do it to one side, I do it to the other side. I end up getting y is 1 times 1 is 1 on top, and 100 times 2 is 200. So that's what I end up getting for the B part. This is my answer down here.